Hello everyone, my name is Kamini Tanwar. I am a faculty in Ajay Kumar Garg Engineering College in IT department. So today I am going to discuss a topic from the subject programming for problem solving, and the topic is searching. Uh, in my previous video I have already discussed about the linear search. So this is the continuity lecture of that previous lecture. So in today's lecture I am going to discuss the second technique of the searching, that is binary search. So before starting today's lecture I will recall the previous lecture, that what is searching. And as I have already discussed about searching, that what is searching? Searching is basically a process of finding a particular elements among several given elements. Okay. Then I have discussed that why we need searching. Basically, we require searching for finding a particular element from the. Uh, as you know that in our computer science we have a collection of data we are stored in our system. So for that particular file, from that particular collection of file, if you want to search a particular simple file, or from a collection of database we are finding a single record from that, or we are having number of elements in an array, from that array we want to, or we have to find simple elements. So that time we require the searching. So the searching may be from the we have trees, we want to found a simple node from that particular trees. We are having graphs, from that graph if you want to found the edges or vertex. So searching is required basically in our database. So because it is where we are having a collection of data, from that data we want to find a particular data. So that time we required searching. That is I have already discussed in previous lecture. So now after that we are having this two we are getting two options, or we are getting two option, that first we are getting the unsuccessful search, or second we get the successful search. So these are the two options we are getting when we are doing the searching. So then we have discussed why do we need searching. Then now in today lecture I am going to discuss about the second technique. We have already discussed about the linear search. Now in this lecture we are going to discuss about the binary search. That what do you mean by binary search? That I have already discussed that this is the interval search technique. Means one we have sequential search, second one we have interval search. So in this technique we are going to discuss about this interval search, and the example of the interval search is binary search. So in this lecture we will discuss all about the binary search. So these we have already covered in our previous lecture. Okay, now first of all, what do you mean by binary search? As we have discussed linear search, we are seeing all thing in linear search, that how linear search work, how we are finding the a particular element with the help of linear search, the algorithm of linear search. And also we have discussed about the complexity of the linear search. But now in second type of searching, that is binary search. What do you mean by binary search? Basically this is the fastest one. Means it is fastest searching techniques. Searching why it is faster? Because it's work on the principle of divide and conquer techniques. Now what do you mean by divide and conquer techniques? Why it is fastest? It is fastest because it work on the divide and conquer technique. And what is this technique? Basically this technique is work on the dividing a particular, like we are having these suppose we are having the elements in an array. Now what is divide and conquer? Divide and conquer techniques tells that we have to divide these array into two parts. We have to divide this array into two parts. First you can say this is the first interval and this is the second interval. With the help of some searching techniques we are applying the in this array, on this array elements, searching techniques. By that searching technique, what will happen here? We are dividing this array into two parts. First, after that we are dividing two parts, again we are dividing this into two parts. Similarly we get the element. With the help of these searching, with the help of these divide and conquer, we get the element that we want to find. That means in this binary search, what we are doing here, we are dividing the particular elements, and then we are applying again binary search algorithm over them, and then we are finding the elements. With the help of this, what we are doing, we are just reducing the searching, reducing the execution time, because if we are searching in this particular elements, we are not tracing or we are not executing these elements, we are just removing or discarding these elements, because we have the algorithm that tells that we have only search in this part. So this is the basic idea about the divide and conquer. We will more uh, study about this in detail in this lecture. Okay, so basically first we get when we get about the binary search, that is, it is very fastest searching algorithm. Second, the one is its work on the principle divide and conquer. And the third point is, that is very important about the binary search, that is, if we are applying binary search, we have one condition, that is the uh, that is the array that we are taking must be sorted array. Now what this word is very important about the binary search, that the array must be sorted. Now what do you mean by this sorted? Sorted means we are arranging the array either in increasing order or either in the decreasing order. Like we are having these okay, for example, I am taking the elements in an array. Sorry, I am taking two array. Suppose this is one array, I am taking A, and the second one is I am taking B. So I am taking here two array. Now in this array, I am taking the element 10, 50, 60, 20 or 30. These are the elements of first array, and in second array, I am taking 10, 20, 30, 40, 50. So you can you can recognize, or you can compare both the arrays, that the first one is our array element are in unsorted manner, means we are not arranging these in up either in a ascending order, either in a descending order. But in second array, or the element of second array, we are having 10, 20, 30, 40 and 50. That means these elements are in sorted manner. And in which manner these are arranging? In ascending order. Okay, in ascending order we have arranging these array. That means this is the sorted array, or this is unsorted array. You can say these are the unsorted, or this is sorted. Now I think you all get about the word sorted. What do you mean by sorted? That means either the element arranged in the increasing order or either in the decreasing order. The elements of the array must, and the condition for the binary search is the array's element must be in the sorted array. That means we are not going with this array, we are not applying the binary search on these elements of the array. If you want to find any element, we are not going to use this array, we are going to use this one, that is sorted array. Or if you want to search in this particular array, then what you have to do, we have to first make it in a sorted manner, then we are going to apply the binary search. So the third point, I think it must be clear that if you are going to apply a binary search in a array or in a elements over the elements, what is the condition? The condition is the elements of that array must be in a sorted manner. Okay, now like here I have written that either these are the ascending order, or in the if you are taking the numbers, if you are taking the numbers, the element must be in ascending order or in the descending order. By default, if you are not mentioning any sorted order, then we are taking the elements of the array must be in the ascending order. And if you are taking the string elements, like we are taking the alphabets or any string, like I'm using Ram and Sham like Meena. These are the some example. If I want to arrange these in if you I want to sort these string elements, then what we have to do, we have to arrange these elements in a manner of in dictionary order. What do you mean dictionary order? Like I'm taking alphabetically, that M, after that R, after that S. Okay, so these are the orders, means the our element should be sorted in this dictionary orders. So this about all these about the binary search sorting element. After that, if we are applying you want to apply the search in unsorted array, then what we have to do, first, that I have already told, that first we have to sort the elements of the array, means we have to sort the array by using some sorting techniques. So now what do you mean by sorting techniques? We have not discussed here the sorting techniques. Sorting techniques basically used to sort the element either in the ascending order, either in the descending order. So we are having three or more type of sorting techniques. We are having, I'm giving some example, like we are having bubble sort, one example. Second, we are having algorithm like insertion sort. We are having selection sort. These are some sorting techniques which we are going to discuss in further videos. So with the help of these sorting techniques, we are going to sort our elements of array. Okay, so and then after that, first step is this. After that, what we have to do, we have to apply the binary search algorithm. So I will brief about all these, that what we have to do if we are applying the binary search over elements of array. Then what we have to, if our suppose we are having the elements that are already sorted, then no need to sort again. Okay, then we are just directly apply the algorithm. But if the elements are not sorted, then what we have to do, we have to first sort the elements of that array, and after then only we are going to apply the binary search. So this is all about the binary search. This is the brief description of the binary search. Now I'm going to take one example of binary search. So here I am taking a array that is suppose this is the elements of an array, and from these elements we have to find an element that is 23. Suppose we have to search a element 23 in the particular elements of array. Now what we have to do here in binary search, we have three basically steps, or what we have to do, we have to first calculate the midpoint. What do you mean by midpoint, or we can say mid element? That we are having some lower bound, we have to check what is the lower bound, then we have to check what is the upper bound, or you can say the lower limit or the upper limit. We have to find that limits, and after these getting the limits, we have to find the midpoint. And what is the formula of mid element? We are lower plus upper divided by 2. This is the first step. You can say the if you are applying the binary search, then the what we have to do, first step is we have to calculate this mid element. This is the mid element we have to calculate. As I if I am talking about the linear search, what we are doing there, we are just taking the element that we have to search, and we are going to compare with the first element, then we are compare with the second element, then we are compare with the third. Means sequentially we are comparing, and at the position we are getting that particular, or we are just getting that elements, we just print that element found at this position. But in binary search, what we have to do, first step is we have to get the sorted array. After that, what you have to do, we have to calculate the mid element. And for mid element, what the things we needed the lower bound, we needed upper bound. So in this example, what is the lower bound here? Here lower bound is 0 and upper bound is 9. So you can write lower bound is 0 and upper bound is, yeah, you can say lower limit is 0 and upper limit is 9. So if you want to calculate the mid, then what we have to do, put here 0 plus 9 divided by 2, you get 4.5. Okay, this is the mid element. Now here is one question arise that this is 4.5. 4.5 means we have a mid element, but 4.5 is not a position. So what we have to do, we have to take this this fourth, this 4 number, that means the integer part we are taking. Why we are taking integer part? Because we are founding the element. We are founding the element at the position of mid. So because we know that we are our location and our position never be in a floating point. So we are basically taking the integer part, because location or position can never be in a floating part or never be in a real parts. That's why we are taking the integral part. So from here we calculate our midpoint. This is not the mid element position, you can say. Okay, mid element position we are getting. So fourth, you what is the mid position location? 4, number 4. That means at position 4 we are having our mid element. So I hope up to this you all get the point. The first step I think clear. After this first step, what we have to do, we have to calculate, we have to check where the position is, where the element is lie. How we can check? We are going to compare that mid element with the with our searching element, the element which we have to found, which we have to search in our array. We are going to compare with that mid element. Okay, so like suppose we are having our search element, suppose we are searching search element equals to 23, and mid element we are having 16, because we are getting with the help of mid position we are getting position 4, and at 4 what the number is placed here, what element is placed here, that is 16. Now what we have to do, we have to compare this is the mid element position, sorry, mid element is 16, because at position 4 which element is placed here, 16. Okay, now the second step what we have to do, we have to check where the search element lie. And how we have to check? We have 3 conditions, we have 3 steps here. First we have to check the mid element is equals to search element. Okay, we have to check this mid element is equals to search element or not. If this condition is true, okay, if this condition is true, then what we have to say, that our search element is that position of the mid element. So if this condition is true, then you can print the search element. Okay, print element mid element position. Sorry. Okay, if this condition is true, you can say at the position of mid element our search element is placed there. Okay, that means this position means you can say our search element is at position of the mid element position. And what is the mid element position? Mid element position is 4. That means at location 4 we get 23. This is the first case when our mid element is equals to our search element. But if it's not true, like in this example, we are having 23, that is not equals to 16. That means this case is not true. Okay, this is the first thing we have to check. But if this case is not true, then what we have to do? We have to check the second condition. And what is the second condition? Second condition is we have to check our mid element is greater than our search element. search element. Now what is our mid element? Our mid element is 16 and our search element is 23. Is this condition true? No, this condition is again not true. That means our mid element, if this condition is true, okay, first we have to see one thing. If this condition is true, suppose this condition is true, our search element is greater than our smaller than our mid element. Okay, then what we have to do, we get to know that our search element must be present in the left side of the mid element, that because the mid element is greater and search element is smaller, like this. Now what we have to do, we have to check in particular this array. We are not going to check the element in this array if our element is smaller than our mid element. Okay, so what we have to do for that, again we have to calculate the mid. So for mid, what we have to do, we need lower bound and upper bound. We need, because we have to calculate the mid element again, or mid position element. So okay, so what is lower bound here? In this, you can check in this particular array. So what is the lower bound here? Lower bound is 0, and what is lower bound is 0, and what is upper bound? Now you will see that upper bound here, we don't know what is the upper bound here. So what we have to do for that upper bound, we have to subtract 1 from the mid. Why we have to do this? Because now we are taking this particular array, and in this array we know that our element is not present above, or not present in that particular array, or the element, because the element is smaller than the mid. That's why we are checking the elements in this particular array. So now the new upper bound must be mid minus 1. We know what is the mid element position, that is 4, and minus 1, that is 3. Now the new upper bound is 3, that means 0 and 3 is the new elements that we are going to check. In this array we are going to check again our search element. Okay, but if this case is not true, this is the second case. Now we are having the third case. What is the third case? If right now we are checking if the element mid elements if the mid element is smaller than search element. This is the third case. We have go through with all two we have discussed. That first one is we check either the element is equals to or not. Second one, we have checked the element is greater or smaller. The third one is the element, if the element is greater than the mid element. That means this is our mid element, and the element we are going to search, that is the larger. That means we are going to search in this particular array. Now what we have to do, we are not going to check the element in the left side of the array element. We are checking this in particular in this array. So what we have to do for this, again we have to, if this condition is true, what we have to do, again we have to calculate the lower bound, upper bound. And why we are calculating these lower bound, upper bound? For the mid. Now for mid, what we have to do, upper plus lower divide by 2. So now what is the upper bound? We know this is the upper bound, 9. We no change, because we are searching the element from here to here. So in upper bound there is no change, but in lower bound we have again a change, because we in starting or in initial we are taking lower bound 0 at the starting. But now what we have to do, we have to change our lower bound, because now we are just taking this particular array element. So in this array element, what is the lower bound? We know the midpoint, or we know the mid position of the element. That means that is 4, and we are not taking that position. We are just taking 1 plus position, that is 4 plus 1, or you can say mid plus 1 we are taking. That means we are taking 5 plus 9 divided by 2, that is 7. Now we are getting a new mid element position is 7. Like this we are checking our program, or we are doing the binary search. So in particular binary search, what we are doing first, we are finding the mid element with the help of lower bound and upper bound. After that, what we have to do, we have to check what either the element is equal with the mid element, or greater than with mid element, or in the smaller than with mid element. If the element is equals to mid element, then we can say this element is found at this set position. But if the element is not equal to mid element, then what we have to do, we have to check the element in the left hand side. If the element is smaller than mid element, we are checking in the left hand side. If the element is greater than the mid element, we are checking in the right hand side. Similarly, if again we are applying the binary search on that particular divided or or interval of the elements of the array, then again we are searching, and we are just repeating this process until we are not getting the searching element, we are not finding that particular element. So this is all about the binary search. So now this is one example. If here, so in this example, suppose we are having elements of array. These are the example where we are getting the, if we are getting, we are as in earlier I have told, there must be two cases. Once we are getting the element, or second if you are not getting the element. So if you are that means if you are successfully search the element, or unsuccessful search the element, that there are two cases. If the first case, if the first example shows the successful search, and this is unsuccessful search. Why? If we are getting the successful search, means we are finding the element x equals to 110, or we are searching this element in this particular array, then we get the element at the position 0 1 2 3 4 5 6, means at 6 position we are getting the element. So we print output 6, because element 6 is present at the index, sorry, element x is present at the index 6. But in the second case, if you want to search the element x equals to 175, then if you are just searching the element at 0 position, this is not matched, 2 3 4 5 6 7 8. So if you are checking on every position, we are not getting the element, then what we have to print, we have to print -1. -1 present that this is, the search is unsuccessful, we do not get that particular element in this particular elements of the array. So these are the two cases we are getting in the binary search, or in any search we are getting these two cases. That first, when we are getting the element, then we say the search is successful. If we are not getting that element, then we say the search is unsuccessful. Okay, so I think the idea about the binary search, all you know that what are the binary search. That binary search is searching algorithm, as you know, and what in this binary search we are using the sorted array, and on that sorted array we are repeatedly applying the search interval in half, means that we are repeatedly applying divide and conquer rule. Okay, so in binary search, what we have basically we are getting the, means with the help of binary search we reduce the time complexity, that is O log n. So as you compare this search with the linear search, that in linear search the complexity is time complexity is larger than the binary search. Why larger? Because in the linear search we are traversing each elements up to the last element, but in in binary search we are dividing, we are applying the searching technique in half part. So the time complexity is reduces here, the execution time is reduces here, because every time we are just we are just compiling the only half part of the array, not the complete part. That's why the time complexity is reduced here. So this is the algorithm of binary search. So at beginning what we have to do, we have to find the mid element, and after the mid element what we have to do, we have to search, we have to calculate that the search key is equal to the mid element or not. If search key is this is all I have already discussed, that if search key is less than the item, then what we have to do, we have to narrow the interval of the lower half. That means we have to mid minus 1, that we have to do mid minus 1, that means lower bound. Okay, and if the otherwise you can check the lower upper bound. Okay, if the means if it is reversed, that if it is not less than, if the key element is not less than, if a key element is larger, then we are checking in the other half, upper half part, and this process will be repeatedly until we get the searched element. Okay, so this is the basic algorithm code, that what we have to do in binary search. Suppose what are the things we are having. Okay, the first condition before binary search, first is we have to check that this is the sorted or not. But the second thing we must check, lower bound must be less than higher bound. That what does it mean? Suppose we are having these elements, that means this is our lower bound and this is our upper bound. So this is 0 1 2 3, that means I'm talking about lower bound must be smaller than upper bound. If this is true, then only you can come here and you can execute. But this is false, that means this is the false case where what we are doing, upper bound lower bound is greater than upper bound. What does it mean? That means we are having only one element in our suppose this is the array, and this is our lower bound and this is our upper bound, so this is 0. So condition is lower bound 0 is smaller than upper bound. Sorry, 0 is small, yes, here 0 is all, upper bound is again 0, lower bound is 0. That means here this condition is if we are having only one element, or if we are having only not the more than one element, then where we are going to search the element. That means the condition must be satisfied that lower bound must be smaller than higher bound. If this condition is true, that means lower bound is greater than higher bond, that means this bond is greater than this bond. This means this condition, if you can say this condition, then we return false. That means we are not going to search the element, we are not able to apply this binary search over that particular array, because there are not element present in that array. So okay, but if this condition is false, okay, if this condition is false, that means lower bound is not greater than higher bound, then we are executing this else part. In else part, we are having three cases that I have already discussed in previous slide. That what are the three cases? Okay, before that we have to calculate the midpoint. We are already calculate. According to that midpoint, we are having three cases: first, second, and this one the third case. Okay, now you can check. If our search element is equals to our mid element, then what we have to do? We have to return mid, that our search element is mid. But if our search element is greater than mid, then what we have to do? We have to search the x element on the right hand side. Okay, that I have discussed, that we have to search the upper part of the element. We are going to searching in that element. So if this condition is true, then what we have to do? We have to return binary search. That means we are going to again applying the binary search. But what are the conditions? That we are having different array, we are applying the binary search on different array, because suppose this is the array element and our element is present on this side, then what we have to do? We are taking this element of this array, and at the starting we are taking with or going with the complete array. But after finding that this element is present on the right hand side, then we are taking only this right hand side part of the array, and we are applying the binary search over there. Okay, after that what we have to do? We have to again what we have needed, the search element. Then the high or low means upper bound and lower bound. Then our lower bound must be changed, because you can see the upper bound is same, but the lower bound must be changed. Then what we have the lower bound, or what we must have, that mid plus 1 is our new lower bound. Okay, for the case of x is greater than mid. But in the second case, when the search element is So first case is if this condition is true, then you are going with this. But if the condition is false, that means our search element is smaller than our mid element. Then what we have to do? Then we have to again return binary search, okay, over the new array, that is AAR. That means now our element is present in this side and we are going to apply the searching in this array, that is the new array. For this array, what we needed again lower bound and upper bound, and for the lower bound is our same, but the upper bound is different. Why upper bound is different? Because we are searching over on the this particular array, not the complete array. So the upper bound is here 1. Why 1? Because here we are doing mid minus 1. We know that our mid is 2, so 2 minus 1, that is 1. So we are using this particular algo for the binary search. I hope it is clear to all. Now this is basically one example on binary search. Okay, so this example is basically our C program. So in this first line we are taking a array A150, then first we are declaring the variables, then we are entering the size of the array. Suppose we are taking some elements here, then with the help of printf we are printing that elements. Then in this we are basically, okay, here we are taking the size of array, okay, here we are just printing the size of array. Then with the help of this for loop, what we are doing, we are just entering the elements in an array with the help of this. Now what we have to do, we have to search the element. Suppose we are, so again we are entering the element that we want to search. Suppose here we are entering the element that we are going to search, okay. Then at first we are taking 0, that is our lower bound. We are taking lower bound this, and this is our upper bound, okay. So why this is, suppose size is 5, then 5 minus 1 is 4, 4 is our lower bound. So this is the logic. Basically you have to see this logic, okay. So in this logic you can see, first we are checking the first condition, first is smaller than equals to last, that means upper lower bound must be smaller than equals to upper bound. Then only we can enter into the loop, and then we are calculating the mid. Here we are calculating the mid, then we are here checking the mid, okay. These are the that I have already all discussed, that we are checking. And then if the condition is true, if the middle we are checking these, that where the middle element is basically present, and again we are just repeating the loop, okay, until we get the search element. So element is found at the position this, then you can say here you are going to just stop at the break is basically used to stop the execution and just come out from the complete execution. Here at last we are again checking first, if the first is greater than last. This is when this condition is not true, you are come here, you check, and you are you print that element is not found. So this is the example of binary search, and you are getting, suppose I have just, this is the output, that entering size 5, and these are the 5 element. You want to search the element 20, then at 20 position you get the, sorry, at position 3 you get the element 3. So this is the time complexity, as I have already discussed, that this is the, it reduces the time complexity, and the time complexity of the binary search is O log 2n. And why it reduces the time complexity? Because the number of it reduced to the half of there. That means here the execution time taking, or the execution is lesser than the linear search. That's why the time complexity is reduces here. That means for n elements we are basically doing log 2n iterations, okay. So this is the answer. This is one example. If you want to see, or if you want to learn more about that, this is the element where these are the array where we want to search the element, suppose 15. So what we have to do, we have to calculate like suppose in this particular example, this is the array, and if you want to search the element 15, then these are the steps that with the help of these you can find the element. Like we are having upper bound 0, lower bound 6, sorry, upper bound 6, lower bound 0. Then what we have to do, we have to calculate mid. With the help of this we are having mid 3, then what we have to do, we have to check this mid with the element, means because we are having the element 15, and what is mid? Mid is at our position 3. So at position 3, which element is present here? 20. Now we are just comparing this 20 with 15. So after comparing 20 with 15, what we have to check, that is this element equals to, greater than, or less than. So in first case, this element is not equal to, that means this element is smaller than the mid element. Then what we have to do, we have to mid minus 1, because the element is smaller. Again, we are, if the now we are having the mid sorry, the lower is at 2, and upper is this is our upper and this is our lower. Now again, we are, what we have to do, we have to check again, find out the mid. So new mid is 1, as new mid is 1, because 2 is upper, so this is upper, this is lower, so 2 plus 0 is divided by 2 is 1. So new mid, this is our new mid. Now what we have to do, again check this mid is greater than, equal to, or smaller than, with the search element. Again, you found that the element is not equal to mid. Now what we have to do, we have to check this condition. Again, the mid element is we are having mid element is 10 and search element is 15. Now our mid is smaller than search element. Then what we are doing, we are just again searching element in the second in this side, because our, now this is the array where we are doing, this is our mid. We are comparing with both these two elements. Now what we get, that the searching element is greater than the mid element. So again, what we have to do, we are just taking this particular array. So in that, what we are doing, we know that this is our upper bound we are having 2, okay, but we are, our lower bound, what is our lower bound? Mid plus 1, that mid is 2 plus 1, that is, mid is 1 plus 1, that is 2. Now you getting a point here, that upper bound and lower bound both are equal. That means our iteration must be stopped here. We are checking the condition, our mid and the search element is match here at this point. So you can say at index 2 our search element is present, and we can say the search is successful, and at that time we are going to stop our searching. So this is all about the binary search. I hope this will helpful for you all. So that's all for this lecture. Thank you. Jai Hind all.